Hey everybody, I'm back, and now we're going to look at these measures of central tendency using Google Sheets. It's a very useful tool. This is a document called Samples of Human Height. We took a sample of 25 different people, each one of them having a very interesting name. By the way, these are real names. There actually is someone named Facebook Miller and another individual named Olive Garden. And we're looking at their heights given in inches. This document is available on our course management software. What I'd like you to do right now is open it up and then make a copy of it so that you can edit it and call that copy Samples of Human Height dash and then your name. Okay. So pause the video, go ahead and do that, and then we'll get started. Okay, here we go. So we have 25 different heights here and we want the mean. I'm going to put it in this cell right here. This is G3. What you need to do is start by putting the equal sign, and then there is a formula called average. And all you need to do is tell Google Sheets what cells you want the average from. Now, there's a couple different ways that you can do this. One is that you can click on the first value and then hold down the Shift key and then click on the last value. And you'll see up here that in the formula space, you get C3 and then a colon and then C27. Now, I personally never do that. I like to use the keyboard. So I type in C3 colon C27 end parenthesis, and then you hit enter. And there is the mean height, 64.8 inches for the people in this group. Okay, so now what about the median? Well, there's a formula for that, and it is, surprise, surprise, median. And then we want to use the same range. So the median is slightly higher than the mode, slightly higher than the mean. And then finally, we want the mode, and the formula for that conveniently is mode. So first thing for today is you need to be able to use Google Sheets in order to come up with those three values. So know those formulas: average, median, and mode. Pretty simple, right? So now the second part of our discussion is we're going to use this software to look at what happens if we throw an outlier in the mix. So imagine that we have the same set of data. I'm going to copy this region. See how I moved the cursor over it? By the way I do that is I click on the first one, I hold down the Shift key, and then you can either move the cursor until you've covered the region, or you can just use your mouse. And then I am going to copy. Now, there's two ways that you can copy. One is that you can go to Edit, and then you can choose Copy. Or the other, what I like to do is I do a Control-C. Okay. So now I copied that data set. You should see that there's this little like sort of perforation dashed rectangle around the area that we copied. If you just move to the top rectangle of the new column and then you do a paste. Now paste, same game. You can either go here and choose Control V, or you can do what I like to do is actually within that space, go Control V and it'll paste. All right, so there's our data set. I just copied it. Now imagine that I add one more value, and this value happens to be the tallest man in recorded history, who was 8'11" inches tall, which would be 107 inches. So now we're going to have one extra value in the data set, and I want to look at what that does to the mean, the median, and the mode. All right, so right here, let's do those formulas again, but we're going to be using this column right here. Good challenge. Pause the video right now, and then see if you can come up with this, and this on your own. All right, so I've unpaused the video here, and I have our three values. Boom, boom, boom. Let me show you the formulas so that if you didn't get these, you can see where I got them from. For the mean, it's average from D3 to D28. Remember that we're in a new column now, so we're in column D, and that we have one extra value, so it needs to go to 28. The other two are similar. Median on that region, and then mode on that region. Okay, now let's look at what happened. I see that the mean changed quite a bit. In fact, how much did it change by? I can do equal to this value minus this value, just by throwing in this one really, really tall dude, this outlier. It took the mean and it increased it by 3 full inches. That's a lot of height for an average, right? Now, if you look at the other two, I'm just going to take this formula and I'm going to copy it here and here. You can see that the median and the mode, they didn't move at all. So the outlier did not have an effect on them. And that's the other big thing that you want to get out of this, is that when we have outliers in a data set, they are going to affect the mean, but they are not going to affect the median and the mode. So finishing up here, I'd like you to get your composition notebook out, and let's make some notes about what we just learned about outliers. First thing is this. We discovered that the mean changed quite a bit, and there are some words, there's some language that we're going to use for that. We say that the mean is sensitive. It has strong sensitivity, strong feelings. It is sensitive to the presence of outliers. So here's what that means. Do not use the mean to describe the center when outliers are present. Okay, that's the mean. Now the other two are the median and the mode. Okay, and the median and the mode, they're a couple of sociopaths. They don't have strong feelings. They don't get sensitive. So we say that they are not sensitive to outliers. And that's actually a good thing. That means that you can use either when outliers are present. We'll talk more about how to choose which kind of measure of center in a future video, but let's leave it there for now.